Hello pre-calc students, we're starting our unit on exponents and logarithms, and on day one we worked through several examples in class. You can see that our classwork was the odd problems, and then your homework will be the even problems. And we started with a review of exponents from Algebra 2. If you need further review of exponents from Algebra 2, you may want to look at another video from the warm-up. Alright, in problem 33, we have the cube root of 216 squared. Now the cube root of 216 happens to be 6, but if that's not something that you can figure out in your head, you could make a factor tree for 216 where you just split it into its prime factors. So like 2 times 108 and 2 times 54 and 6 times 9, and then 9 is 3 times 3. And 6 is 3 times 2. So anything that shows up 3 times, 1, 2, 3, 1, 2, 3, can come out of the cube root. So 2 times 3 is 6. And then you need to square your 6, so you get 36 altogether. In problem 35, you have the 7th root of negative 128 to the 4th power. Now again, negative 128 is a pretty big number, and you can split it into its prime factors to figure out. I'm going to deal with the negative later and just do the 128 to start. So that would be 2 times 64 and 8 times 8, 4 times 2, 2 times 2, 4 times 2, and 2 times 2. So in the end I have 1, 2, 3, 4, 5, 6, 7 2's. That would be 2 to the 7th power. I'm going to write it that way because there's a lot going on here. So I have 1 over the 7th root, and because of the negative here, it's actually negative 2 to the 7th power, and that's also going to be to the 4th power. So the 7th root and the 7th exponent, those can cancel. So you have 1 over negative 2 to the 4th power, and that would be negative 2 times negative 2 times negative 2 times negative 2, which gives you 16. So your final answer is 1 over 16. Okay, if you feel like you know how to do these problems, then feel free to pause the video and try them on your own before you watch my explanations. In 45, you have an exponent outside the parentheses, and so the rule for power to a power is that you would multiply this exponent times this one, times this one, times this one, and then even for this 256. So I have negative 16 times negative 1/4, which gives you 16 over 4. That gives you f to the 4th. Down here I have negative 1/4 times negative 4, which is 1, so that just gives me h, and negative 1/4 times positive 4, that gives you negative 1, so I have g to the negative 1. Now 256 also happens to be a power of 2. You can make a factor tree. Another way you could do this is if you think it might be a power of 2, just start multiplying by 2. So 2, 4, 8, 16, 32, 64, 128, 256. So that's 2 to the 1, 2, 3, 4, 5, 6, 7, 8. So that's 2 to the 8th. So you have 2 to the 8th, and you're raising that to the negative 1/4. So you are going to multiply those as well, but I just wanted to show you the 2 to the 8th before I did that. So this is going to give you f to the 4. 8 times negative 1/4 is negative 2. G to the negative 1, and h. And if you have a negative exponent, that's really the reciprocal, so that would be like 1/2 here and 1 over g here. And if you divide by 1/2, you would flip it and multiply. So really what happens if you have a negative exponent is it moves to the other part of the fraction, and the exponent becomes positive. So it becomes positive on top. 2 squared is 4, and the 4 moves to the top. G to the negative 1, move that to the top. F to the 4 is still there. And in the denominator, you still have h. Okay. 4951, it says to express using rational exponents. Rational exponents are fractions, and the denominator of the fraction is your root. So a square root, the denominator is 2. And the numerator of your fraction is the exponent. So this would be m to the 6 over 2. And this n doesn't have an exponent, so that's like a 1. N to the 1 over 2. And then you just want to simplify. So 6 over 2 becomes 3. So m cubed n to the 1/2. Okay, here you can rewrite your 8 as 2 to the 3rd. So I have 2 to the 3rd. Actually, let me just keep that in the root for the moment. And then x to the 3rd, y to the 6th. And then I can do power over root. So 2 to the 3 over 3, x to the 3 over 3, and y to the 6 over 3. So that becomes 2x y squared. Down here we have rational exponents, and we're trying to change them so that they look like a radical. So basically we're working backwards. And we're going to do 2 odd problems. So you look here, and this could be a cube root, but this one's a square root, and you want to express it using just one radical. So the way to do that is to get a common denominator. So you have to think of the least common multiple of 3 and 2. So 3 would be 3, 6, 9, 12. 2 is 2, 4, 6, 8. And you can see that the least common multiple of those numbers is 6. So we're going to change these to be over 6. So I have something over 6, something over 6, something over 6. Okay, so 2/3 becomes 4 over 6, because 3 times 2 is 6, 2 times 2 is 4. 1/2 becomes 3 over 6, 2 times 3 is 6, 1 times 3 is 3, and 1/3 becomes 2 over 6. And so now you can have a 6th root, and everybody can go inside. P to the 4, Q to the 3, R squared. It's the same idea in number 59. The least common multiple of 7 and 3 is 21. So you make it 13a something over 21, b something over 21. So 7 times 3, so the 3, and 3 times 7, that goes there. 13 does not have an exponent, so it does not get to go inside the radical. 13 stays out. There's your 21st root, and it's a to the 3, b to the 7. All right, on the next page, we're starting to talk about logarithms. Now, logarithms are the inverses of exponential functions. They undo exponential functions. And if you have an exponential function written in the form, the base to an exponent equals y, you can rewrite that as a logarithm. The base of the logarithm is the same as the base of your exponential. But then this is going to be the log base b of y equals x. So notice that the answer to the logarithm is the exponent from the exponential. So this is why we can say very simply that logarithms are exponents. People think they're more complicated, but they're not. They're just exponents. There are 2 special kinds of logarithms. One is the log base 10. If you're going to do log base 10, you don't write the 10, you just write log x. So this means log base 10. And then the other one is the natural log. Natural log is written ln, and if you see ln, it means log base e. Okay, and e is an irrational number. It's about 2.7, and it's the base of the natural log, and that's very useful in problems like compound interest problems. All right, so let's write the equation in logarithmic form, 1 and 3. So let's look at this. 5 to the 3 equals 125. It looks very much like b to the x equals y. So we're going to write the logarithm, log. The base of my log is the base of my exponential, so that's 5. Then notice that the x and the y, they kind of switched orders. So the next thing I'm going to write is the 125. And then the answer to your logarithm is the exponent. In problem 3, the same thing. It's going to be log base 6. These two switch places, so next comes 1 over 36. And the answer to your log is the exponent. Okay, 7 and 9. Now you might want to try to see if you can change the logarithm back to the exponential. Before watching this, you can pause the video. The base of your logarithm is 2, and the answer of your logarithm is the exponent. So 2 to the 3 equals 8, and that actually makes sense, so you know you did something right there. Number 9, ln a. So it can be helpful to rewrite ln as log base e of a equals 3. Now you can look at this log and change it to this exponential. The base of your log is e. The answer to your log is the exponent, so e to the 3 equals a. Alright, now we're going to solve logarithms. We're going to find the answers to the logarithms, and we're going to do it by rewriting. So I'm going to start by rewriting it. I need this side over here, so my answer is going to be x. The base of my log is 5. The answer is the exponent, and that gives me 1/25. So I need to figure out what exponent would change 5 to 1/25. I know that 5 squared is 25, and then to get the reciprocal, I'm going to need a negative exponent. So my x is going to be -2, because 5 to the -2 power is 1 over 25. In 13, same idea, right equals x, and then you have 7 to the x equals 1. So I just rewrote it as an exponential. Now I have to think what exponent would change 7 into a 1, and actually the exponent is 0, because anytime you have a base with an exponent of 0, that's going to make your answer 1. Okay, 15, right, equals x. This is a good one to try on your own to see if you got it. So you can pause the video right here, give it a try, and then watch again. Alright, your base is 4, your exponent is x, and that equals 64. So you're thinking to yourself, 4 to what power is 64? Well, 4 times 4 is 16, that's not big enough. And then times 4 again, that is 64, so x is equal to 3, because 4 to the 3rd power equals 64. Alright, 17's a tricky one. So I'm going to write 27 to the x equals 9. Now there is no way that I can make 27 into a 9. It's not the square root of 27. It's not going to be 27 to an integer power. But what I can do is I can break both of these down to smaller factors. So I'm going to change 27 to be 3 to the 3rd power. And I'm going to change 9 to be 3 squared. And then the rule for power to a power is that you multiply the exponents. So I don't need the parentheses. 3 to the 3x equals 3 squared. So then, once your bases are the same, you can say your exponents are going to have to be the same too. So you have 3x equals 2, and x equals 2/3. So then if you go back to your exponential and see if this makes sense, it actually does. So 27 to the 2/3, that means that you want to do the cube root of 27, and then you want to square it. The cube root of 27 is 3, and then when you square it, it's 9, so it does work. Alright, 19 and 21. So I'm going to start by rewriting ln as log base e of 1 equals x, and then I have e to the x equals 1. Remember back here, we said 7 to the x equals 1. 0 is the exponent that can change any base to 1. So that's what we get. X equals 0. And then in 21, I have a cube root. I'm going to want to write that as an exponent. But let's first start by writing what we see. We see 6 to the x is equal to the cube root of 1/6. So I have 6 to the x is equal to 1/6 to the 1/3 power. Remember, cube root is the same as 1/3. And then 1/6 is the same as 6 to the negative 1. So 6 to the negative 1 to the 1/3. If it's power to a power, you want to multiply the exponents. So you get 6 to the x equals 6 to the negative 1/3. And then finally, you can just say your exponents are equal. So x is equal to negative 1/3. All right, so that is the end of the first video, and we will have a second video for pages 3 and 4.